Okay, welcome back to Malware Analysis. I'm J. Lavanya, Assistant Professor of CSC Department. So in this video, we are gonna discuss on the topic called obfuscation techniques in build and debug the malware. Okay, so let's see one by one. So first of all, what is meant by obfuscation? It means to make something difficult to understand. Okay, the programming code is often obfuscated to protect some intellectual property or the trade secrets and to prevent an attacker from reverse engineering a proprietary software program. So encrypting some or all of a program's code is one of the obfuscation method. Other approaches include stripping out, potentially revealing metadata, replacing class and variable names with meaningless labels, and adding some unused or meaningless code to an application script. A tool called an obfuscator will automatically convert the straightforward source code into a program that works as intended. But it is more difficult to read, understand, and therefore compromised by potentially malicious parties. Okay, and unfortunately, these malicious codes writers also use these methods to prevent their attack mechanisms from being detected by anti-malware or antivirus tools. There is one incident that occurred in 2020. So that is 2020 solar winds attack. So that is an example of hackers using obfuscation to invade the defenses and launch a successful cyber attack. Okay, so this is about the obfuscation meaning. The next one, why we are going for this code obfuscation. So in general, obfuscation, we can't able to understand it very easily, right? The programming language. So here, the obfuscation in computer code uses some complex roundabout phrases and redundant logic to make the code very difficult for the reader to understand while maintaining its inherent functionality. And this obfuscating the code, also it makes it harder for the threat actors to exploit the vulnerabilities in the application in order to install some malicious code, escalate the privileges, initiate a denial of service attack, that is DOS attack, and hijack some user sessions or spoof user identities. Finally, it prevents the attackers from trying to deceive the users into some revealing some sensitive data such as credentials or financial information or personal details. An attack method that is known as social engineering. And next point, the reader might be a person, it may be a genuine user or a cyber threat actor, that is a computing device or another program. Example, there is malware. The goal here is to distract the reader with a complicated syntax and make it difficult for them to parse the message and determine its true context. So as we have learned in cryptography, right, the senders will be sending some message to the receiver. On the receiver side, they will be decrypting the message so that by means of public or private key based on the algorithms, by means of that, the sender original message can be decrypted by the receiver. So same procedure where the reader can't able to understand the obfuscated code, right? So in order to parse that particular message, he has to use some complicated algorithms in order to decrypt that. So this obfuscation is particularly important to protect the application from being compromised by unauthorized or malicious parties. For instance, a cyber criminal might be looking to understand the application's logic for numerous nefarious purposes, such as to clone the application or root or crash a system, to compromise or exfiltrate some sensitive data, or modify the code to change the application's functionality or the output. Okay, the goal mainly is to distract the reader. If the code is too complex to understand, it makes it harder to reverse engineer the application. Okay, so that is why in malware process they are using this obfuscation techniques. And here is a simplest diagram. So here the original thing will be displaying the login at prompt. Okay, from there we can able to authenticate by means of giving some username or the password and all those stuff. If it displays a failure toast in the sense, again we have to log in again, right? If there is some login, it is easier to understand. And if it is success, authentication success, it will be displaying the success toast message. Okay, so this is the original message. Suppose if it is obfuscated, right, it display the login prompt and you can okay display the failure toast and display the success toast and authenticate. See, all these modules are in different ways, so we can't able to understand whether it is true or whether it is not true, right? So based on some syntax or the procedure, we have to follow. So this is one of the example for the code obfuscation process. Okay, and how does this obfuscation work? So code obfuscation is about making the code's delivery method and presentation more confusing. This obfuscation might involve changing the content of the original code by adding the dummy code, right? Renaming the variables or changing the logic structure or replacing simple arithmetic expression with their complex equivalents and so on. But even with these changes, obfuscation does not alter how the program works. Neither does it modify its end output. Rather, its main purpose is to make the reverse engineering very, very difficult. And in doing such things, it prevents some unauthorized parties and cyber criminals from getting into the code to modify it for their own purposes. Okay, so this is the normal JavaScript code, like where we have used like greeting is equal to hello world, and we are just specifying another greeting, okay, like is equal to 10, and then that product is equal to some greeting into greeting, okay. So this is a simple JavaScript code that any developers or the user can able to understand. But in terms of obfuscated code, see, where they are given like some X variable parsing, okay, they have specified something, right, where no one can able to understand. So this is an example for the obfuscated code, right? And there are so many types of obfuscation techniques like string obfuscation, file obfuscation, binary obfuscation, data masking, control flow flattening, opaque predicates, polymorphic obfuscation. Okay, so all these types we will discuss in the upcoming videos, right? And this obfuscation works aims to preserve the original functionality of the code or data while altering some of its appearance or its structure. So the key method includes some code obfuscation that modifies the source code or the compiled program without changing its behavior, creating a complex convoluted version of the original. And second one, data obfuscation, so it replaces sensitive data with a similar but artificial intelligence, which makes it useless to anyone who shouldn't have that particular access. All right. So this is about the obfuscation. Like examples, in malware attacks, if you take, there are some string encoding and encryption, like where the attackers convert the strings like the IP address or the commands or into some encoded or the encrypted formats such as a base 64 to make them unreadable to some security tools. And packing and compression, The malware authors use some special algorithms to compress and encrypt the executable code. The malware unpacks itself in memory only when running, making it harder for signature-based antivirus to detect. Okay, and next, polymorphic and metamorphic malware. This advanced technique allows the malware to change its code structure with each infection while keeping its malicious functionality, evading the detection methods that rely on some matching known code patterns, and then leaving off the land attack, that is LOTL. So this attackers exploit some legitimate system tools like the partial or WMI for some malicious purposes. They use this obfuscation to hide their commands and activities within these trusted processes. Okay, next, like fileless attacks. These attacks run entirely in the memory while writing to the disk where they could be scanned by the security software. And steganography, a malicious code or the data is hidden within some seamlessly harmless files such as images or the documents to conceal its presence from the users and security systems. Okay, and next, like obfuscation in case of data security, like data masking, tokenization, and encryption. So data masking, like sensitive data, is replaced with fake but structurally identical data. So this is useful for testing or development environments where the real data isn't needed. And next, like tokenization, sensitive information, is replaced with a non-confidential placeholder or the token. And next, like encryption, data is scrambled, like we used to take like X scramble. So data is scrambled using an encryption algorithm, making it unreadable without the correct decryption key. Okay, so this is about some of the real-time examples of this code obfuscation, right? And next is that common obfuscation uh, methods or the techniques. Okay, the first one is that renaming, second one packing, third one control flow, next instruction pattern transformation, and next arithmetic and logical expression transformation, and dummy code insertion, metadata or the unused code removal. So first of all, what is mean by rename? The obfuscator alters the methods and the name of the variables. The new names might include some undecipherable, unprintable, or invisible characters. So this method is commonly used by Java, iOS, Android, and .NET obfuscators. Okay, and next, like packing. So this comprises the entire program to make the code unreadable. And next, like control flow, the code's logical structure is changed to make it less traceable. The decompiled code yields some non-deterministic semantic results, and thus it makes made to look like a static logic. And this logic is unstructured and therefore is hard for a hacker to understand or take the advantage of. And next, like instruction pattern transformation. This approach takes some common instructions which is created by the compiler and swaps them for more complex or less common instructions that effectively perform the same operations while hardening the code. Okay, so this is all about uh, the instruction pattern transformation. And next topic, like arithmetic and logical expression transformation. So here some simple arithmetic and logical expressions are replaced with some complex equivalents that are hard to understand. And next, like dummy code insertion, dummy or ancillary code can be added to a program to make it harder to read and reverse engineer. So like the other obfuscation methods, doing this does not affect the program's logic or the outcome. Okay. And there is next one, metadata or the unused code removal. So here the metadata provides some extra information about the program logic for reverse engineering purposes. So this technique can also improve the application's runtime performance. So apart from these techniques, there are some common obfuscation techniques like a binary linking. So that is combine multiple input executables or libraries into one or more output binaries that reduces the amount of information available to the cyber criminals for possible application exploitation. It also makes the application smaller and simplifies its deployment. And next topic like opaque predicate insertion. A predicate encode is a logical expression that is either true or false. So opaque predicates are unconditional branches or if there statements where the results cannot be easily be determined with some statistical analysis. So inserting an opaque predicate introduces some unnecessary code that is never executed but might be puzzling to someone trying to understand the decompiled output. And next topic like string encryption. So this string encryption method uses some encryption to hide the strings in the executable and only restores their values when they are needed to run for the program. This makes it difficult to go through a program and search for a particular strings. That said, decrypting strings at runtime can adversely impact runtime performance, although the effect is usually quite small. And next, like code transposition. So this is the reordering of routines and branches in the code without having a visible effect on its behavior. Okay, so these are the common obfuscation techniques that is used. Okay, and next we are going to discuss is about how to measure the obfuscation success. Okay, the success of obfuscation methods can be measured using the following criteria. The first of all is strength, differentiation, expense, and complexity. First of all, strength. So the extent to which the transform code resists automated deobfuscation attempts determines its strength. The more effort, the time, and the resources it takes indicates the strength of the code. And next, like differentiation, the degree to which the transformed code differs from the original is another measure of how effective it is. Two ways to judge the differentiation include the number of predicates in the new code and the depth of the inheritance tree, that is DIT, that is a metric that is used to indicate the complexity of a code. A higher DIT means a more complex program. Okay, and next is that expense, and next is that complexity. So expense here, a cost efficient obfuscation method will be more useful than an expensive method, particularly if it scales well for some larger applicants. And next, like complexity, the more layers the obfuscator adds, the more complex the program will be, making the obfuscation more successful. Okay. Okay, so these are how to measure the obfuscation success. And now I would like to explain about the real world malware obfuscation examples. As I told in the beginning of the video, like in the 2001, there is a SolarWind attack. Okay, so that attack, it uses some obfuscated code to evade the detection or the attackers abusing some partial for malicious purposes through techniques like string encoding, dynamic execution, and the use of web cells like JAMA to maintain persistent access after exploiting some vulnerabilities. So other examples involve JavaScript hidden within some legitimate looking files, ransomware like Luna and Lockbit using some packing and encryption to hide their malicious payloads, and the use of polymorphic code that changes its structure with each infection to bypass the signature based detection. Okay, and examples of malware obfuscation is SolarWind attack. We all know in 2020, right? So attackers used obfuscation techniques to hide their malicious activities within the solar wind supply chain. So which involve exploiting some software vulnerabilities, okay, to gain access to systems and deliver their malicious payload. And partial abuse, attackers commonly leverage some partial for some malicious, activities. They obfuscate scripts by encoding the strings, reordering commands, and using some dynamic code execution to hide the true intent of their actions. Okay. And next, like web shell, following the exploitation of the PHP vulnerabilities, attackers installed an obfuscated web shell named Dama to gain some persistent access and further exploit affected servers. And next one, like XLS or HTML attacks. In some phishing campaigns, hackers use some elaborated obfuscation techniques, including some changing some encryption methods and encoding data in base 64 to hide their malicious activities. And it's like fileless malware. Attackers use some fileless techniques such as leveraging some legitimate system tools like partials and WMI to execute the malicious code directly in memory, making it harder for the antivirus solutions to detect. And next, like ransomware attackers. So ransomware strings like Luna and Blockbit use packing and custom algorithms to compress and encrypt their malicious code, which makes it significantly less likely to be detected by traditional signature-based antivirus software. And next, like polymorphic and metamorphic malware. Advanced malware can use some polymorphic code to change the structure with each execution evading detection by constantly altering its appearance to security tools. And next, like JavaScript obfuscation. Attackers hide the malicious JavaScript within the JavaScript files or even within CSS documents. That is, we used to call skimming attack. Okay, where to conceal the operation on some specific websites on all those stuff. And next, like data obfuscation. In some cases, attackers hide the malicious data within the seemingly harmless content of the images, audio files, or other legitimate sealing documents using these kind of data obfuscation, or we used to call as a technography, to conceal their payload. Okay, so these are all some of the real-time examples, right? And now, next, we will discuss about the advantages of the obfuscation. So main advantages include secrecy, efficiency, and then security. So first of all, secrecy. Obfuscation hides the valuable information contained in the code. So this is an advantage for legitimate organizations looking to protect some sensitive information and code from the competitors and attackers. On the other hand, some bad actors, also they will capitalize uh, what you know secrecy facilitated by some obfuscation to hide their malicious code or evade the security tools and launch some successful cyber attacks. And efficiency. And this efficiency, some obfuscation techniques like unused code removal shrinks the program and makes it less resource intensive to run. And next, like security, obfuscation is a built-in application security method, sometimes referred to as application on self-protection. Instead of using an external security method, it works within what's being protected. The application's code to prevent unauthorized access, vulnerability discovery, and intellectual property theft. It is a well suited for protecting applications that run in an untrusted environment and that contain some sensitive information whose loss can be catastrophic to an organization or a user. Okay, so these are the main advantages of obfuscation. Okay, next we will see about what are the drawbacks of obfuscation and disadvantages. So one of the main drawback of obfuscation is that it can it can make the code more difficult to read for the internal developers. So once they have developed in the cell, the people who are developing for an organization, they will be confused. It all makes it difficult for the internal developers. So for example, the code that uses the string at encryption obfuscation method requires decryption of strings at the runtime, which slows the performance. And another disadvantage, it also can be used for some malicious purposes. Okay, so some hackers, they will be using these kind of obfuscation technique for some malicious also. So one example is to initiate the malware and virus attacks. So with obfuscation, instead of developing new malware, actors or the attackers repackage commonly used commodity attack methods to disguise the feature. So in some cases, they include some vendor specific techniques to improve the probability of the success. So malware authors use some obfuscation to fool and evade the antivirus tools and other cybersecurity programs that rely heavily on threat signatures to identify the threat. So these programs typically interpret the code and scan it for some specific features that indicate if the program is malicious. And by obscuring those features, the adversary can make the malware appear legitimate to the antivirus. They might use some comprehensive obfuscation techniques such as ROT13 to substitute the real code with some random characters or convoluted methods like exclusive OR, which hide the data by applying some XOR values to code so that only a trained eye would be able to decrypt it. Either way, the antivirus might not detect for threat, resulting in a successful malware infection and a potentially hefty payday for the malware author. So threat actors might use these kind of de-obfuscation techniques to undo the obfuscation. So these techniques include program slicing, which involves narrowing the program code to just the relevant statements at a particular point in the program, and compiler optimization and program synthesis that are some of the de-obfuscation techniques. Okay, so we have discussed about uh, what are the drawbacks of using this obfuscation, right? And what is meant by a de-obfuscation? Okay, so that just you note it down. It is a reverse code that has been deliberately made complex, difficult to understand to protect it from tampering or reverse engineering. Like common methods what we'll be using for de-obfuscation is that static analysis to examine the code without running it, or dynamic analysis to observe the code's behavior during the execution, or symbolic execution to analyze the code logic, and program synthesis to learn some semantics from the input or output behavior. Like tools and methods such as abstract syntax tree, that is AST, SMT solvers, and taint analysis are employed to automate and simplify this process. Okay, and manual techniques like code formatting. So using a JavaScript beautifier or some similar tools, you can format the obfuscated code into a more readable structure. And like manual analysis, again security professional, they'll be manually analyzing the code thereby to identify the pattern variables and so on. And there are some advanced techniques or like automated techniques. First one like static analysis, dynamic analysis, symbolic execution, taint analysis, and then satisfactory modular theory solvers, that is SMT, and then program synthesis, and then hybrid approach. Okay, so by means of these stuff, they can go for techniques like in de-obfuscation. Okay, so this is all about the drawbacks of obfuscation. So in this video, we have discussed the topic called obfuscation. So what is meant by obfuscation and why we are going for this code obfuscation technique, and how does this obfuscation work, right? And what are some of the common obfuscations that are used, like renaming, tagging, control flow, instruction pattern transformation, dummy code insertion, right? And so on. And next, like we have seen how to measure this obfuscation success, and what are the advantages of using this obfuscation, and what are the disadvantages of using this obfuscation, right? Okay, and we have seen about obfuscation. So, and what are the real-time examples of going for these kind of uh, obfuscation techniques. So, in the next video, we will see about the types of obfuscation in detail. So, thank you all. Thank you.